In this video, I'll be going through question 16 from the 2013 exam. I'll assume you're familiar enough with the simplex algorithm that I don't have to explain all of the working details. If you need some further assistance on the simplex algorithm, refer to some of the earlier questions on the exam. The first thing we want to do is make sure that all the entries we're working with are non-negative. So we find the most negative value in our table and add the absolute value of that to all of our entries. Here, our most negative value is -2, so we add 2 to every entry in the table. The next thing to do is to understand the linear programming problem we're trying to solve. This will be maximize W equal to U1 plus U2 plus U3 subject to the following constraints: 3, 0, 5, 0, 4, 1, U1, U2, U3, less than or equal to 1, 1. Note that our values over here are the values from the payoff matrix plus 2. So 1 plus 2 is 3, minus 2 plus 2 is 0, 3 plus 2 is 5, and so on and so forth. So, straight away, we can write down our initial tableau. Note that we have 2 constraints, so we're going to have 2 slack variables. Over here we have our constraints from the payoff matrix, and here we have our usual identity matrix for the slack variables. And we're maximizing U1 plus U2 plus U3, so we have -1 in these entries and 0, 0, 0 in the rest. So the first thing to do is to choose our entering and departing basic variables. We choose our entering variable by finding the most negative entry in the bottom row. All of our negative entries are the same, so we can choose any one that we like. So let's choose U1. Then we'll choose our departing basic variable by looking at the ratios of the resource values with the values in the column for our entering basic variable, provided that the entries in this column are greater than 0. We only have one such value in this column, so that automatically makes this our pivot point. So now we want to turn our pivot point into a 1. Our entering basic variable is U1, x2 stays the same. 3 divided by 3 is 1, 0 divided by 3, 5 divided by 3, 1 divided by 3, 0, and 1 divided by 3. We also want every entry below this point to be a 0. For x2, it's already a 0, so this row remains unchanged. For this row, we want it to be a 0. It started out as -1, so we add 1 copy of this row to this row. That gives us 0. -1 plus 0 is -1. -1 plus 5 on 3 is 2 on 3. 0 plus 1 on 3 is 1 on 3. 0 plus 0 is 0, and 0 plus 1 on 3 is 1 on 3. Now we repeat the process again. We find our most negative value, which is in the U2 column. And again, we only have one positive value in this column, so that automatically makes our pivot point 4. So, we'll repeat the process. U1 stays the same. Our new basic variable is U2. We turn this 4 into a 1. and we make sure that all the values in the columns above and below are 0. For U1, it's already a 0, so it stays the same. We want to make this entry equal to 0, so we add one copy of this row. You get a 0 here. 0 plus 0 is 0. 1 on 4 plus 2 on 3. That's equal to 3 on 12 plus 8 on 12, which is 11 on 12. So that gives us 11 on 12 in this entry. 1 on 3 plus 0 is 1 on 3. 0 plus 1 on 4 is 1 on 4. 1 on 3 plus 1 on 4 is 4 on 12 plus 3 on 12, which is 7 on 12. So we get 7 on 12 in this entry. There's no more negative values in the bottom row, and that means the simplex algorithm's done. Now that we've finished the simplex algorithm, we can extract all the information we need from the final tableau. Let me just relocate it over here. Now, our values for u are given by the values in the right-hand column over here. So we have u1 is 1/3, u2 is 1/4, and there's no entry for u3. So u3 is 0. Our values for x1 and x2 are given by the values of x1 here and x2 here. So x1 is 1/3 and x2 is 1/4. In order to calculate our optimal mix strategies, we'll have to know the values of u1 plus u2 plus u3, which is 1/3 plus 1/4 plus 0, which is 4 on 12 plus 3 on 12, which is 7 on 12. We also have to know x1 plus x2, which is 1/3 plus 1/4, which we've just seen is exactly this, 7 on 12. The probability that player 1 should make move 1 is equal to x1 divided by x1 plus x2, which is 1 on 3 times 12 on 7, which is 4 on 7. The probability that player 1 should make move 2 is x2 on x1 plus x2, which is 1 on 4 times 12 on 7, which is 3 on 7. So the mixed strategy for player 1 is P1, P2 given by 4/7 and 3/7. We can do part C immediately from here as well. We have the probability that player 2 should make move 1 is u1 on u1 plus u2 plus u3, which is 1/3 times 12 on 7, which is 4 on 7. The probability that player 2 should make move 2 is u2 on u1 plus u2 plus u3, which is 1 on 4 times 12 on 7, which is 3/7. And move 3 is 0 because u3 is equal to 0. So optimal strategy for player 2 is Q1, Q2, Q3 given by 4/7, 3/7, and 0. For part B, there's two ways you can go about it. I'm going to go through the easy way. You take the reciprocal of the value in the bottom right-hand corner of the final tableau and subtract the value that you added to every entry in the table to begin with. Our bottom right-hand value is 7 on 12, so the expected average payoff is 1 on 7 on 12 minus the value that we added at the start was 2, and so that's 12 on 7 minus 2, or equivalently 12 on 7 minus 14 on 7, which is minus 2 on 7. This also allows us to answer part D. Because this is a zero-sum game, whatever player 1 loses, player 2 gains. Player 1 is getting an expected payoff of minus something, so player 2 will gain something. So the game favors player 2. And we're done.